Hi all, it's Dr. Lennon here, bringing you the last video lecture for Module 2, Section P6, Rational Expressions. So, in this section, what we'll be looking at is how to deal with polynomials that are set up like fractions. So we'll just jump right in. Basically, what we'll be looking at is finding the domain of these things, and then also looking at ways to put them together by adding, subtracting, multiplying, and dividing. So let's see. Let's say so basically a rational expression. So notice the root is the word ratio, which is where we get the fraction idea from, is something. So this is not a technical definition, I'm just kind of approximating, is something that looks like P of x over Q of x, where P of x and Q of x are two polynomials. And Q of x is not exactly the zero polynomial. So that's basically it. Fraction on top, fraction on the bottom, or one fraction where the top and the bottom are both polynomials. And remember, for a polynomial, you're allowed to have basically any strings of whole numbers multiplied by variables raised to whole number powers. This does include some things, so notice so 1 over x was not a polynomial, but it is a rational expression. We'll also start to talk about domains. So how do we get, so what is the domain? So the domain of a function is all the inputs that make sense. So that's, again, kind of a little ambiguous, but I'll give you an idea of what I'm talking about. So if we have some expression, say we're going to call some function and give it a formula that's a rational expression, say 10 over x minus 3, basically whenever we have a rational expression, division by 0 is going to cause a problem. So the domain of a rational expression is all x values except the ones that make the denominator 0. And the reason for that is division by 0 is undefined. So we want to have something that is actually a defined operation. So in this case, if we look at the function f of x, what's going to cause a problem in the denominator? Well, x equals 3. So for this example, we would say the domain is just x not equal to 3. Because if you plug in 3 in the denominator, 3 minus 3 gives you 0. And that's the only one that's going to give you a problem. Sometimes we'll have more complicated things where you have maybe a polynomial on the bottom, and we might have to factor it to see what the zeros are. So let's try and see if we can find an example of that. I can make one up real quick. Say something like g of x equals 8 over x squared minus 9. My advice to you, whenever you see a rational expression and you can factor something, go ahead and do it, because it makes figuring things out a whole lot easier. It really does. So x squared minus 9, you might look at that and say, well, I think it can be 0, but I'm not sure. But if we factor it using difference of squares from P5, we know it factors into x plus 3, x minus 3. And then, big idea, whenever you have something completely factored, the only things that can make it 0 are the things that could make either one of the factors 0. And real quickly, we see that x equals 3 or x equals negative 3 are going to make the bottom 0. X equals negative 3 makes this expression 0. 0 times anything is 0. And if you plug in x equals positive 3, the right expression is 0. So here the domain would be x not equal to negative 3 or positive 3. We just toss out all the numbers that make the bottom 0. So let's go back and see if we can get a handle on some of the learning guide problems. Okay, so this first pencil problem number 3, so they don't even give the function's name, they just say, okay, here's the rational expression, tell me which ones we need to exclude. So here we need to exclude x equals 3. So they actually tell you which value, they specify it in terms of exclude from the domain. If you would write the domain, you might write something like domain x not equal to 3. That's another way of showing that it's excluded. But notice 3 is going to be the only thing that's in the bottom. If you want to show a little more work, what you can do is you can just like circle your denominator, set it equal to 0, and solve. And that is how we get x equals 3. All right, let's move on. Oh, my keyboard shortcuts aren't working out for me today, unfortunately. All right, so here's another one, another lovely expression. And what we want to do is just factor the bottom, difference of squares. X plus 5 over difference of squares, make this x plus 5, x minus 5. And I know you want to go ahead and hurry and say, oh, x plus 5 over x plus 5. I can go ahead and cancel this out and write it as 1 over x minus 5. But the thing is, even though the expression will look just like that, we still can't have the value 5 because the original value has to be defined in the function. So, in other words, we still have to exclude this value x equals negative 5, even though in the final expression it doesn't look like it's causing a problem. So in this one, we're going to exclude both of the values x equals negative 5 and x equals positive 5. Okay, so let's move on to the next one. Again, we want to simplify. If it just says simplify, go ahead and just write down the ones, but we still want to remember what we have to exclude. So if you look at the pencil problem, that's what they did here. They factored, simplified, and then this just denotes what value is being excluded. So let's go do that for these next few. You may want to go do a refresher on the factoring because by now we're pretty good at it, so I won't be going through all the details quite as much. The top we can factor in 3, x minus 3, and the denominator is one of those ones where we have x squared minus 6x plus 9. We look at 1 times 9, that gives us 9. We split the bottom up into negative 3 and negative 3. And then when you factor this, I'm not going to go through all the steps, but it'll be x minus 3 times x minus 3. I know I skipped a couple steps there, but you should go ahead and try and fill in the gaps there just to help you with your factoring practice. So the bottom is going to turn into x minus 3 quantity squared. So we can cancel one factor with the exponent here, and our final solution will be 3 over x minus 3. There's no exponent besides 1 now, so we can just leave it like that. And remember, the value we're excluding here is just x cannot be equal to positive 3. Okay. Hopefully that made sense. Make sure you can factor the bottom. That's just a standard trinomial, and you can do it by grouping. And then when you have factors reappear, we can cancel them out. But we still have to pay attention to the numbers they exclude even if they disappear. Okay, this next one, the top one, numbers -8 and -18, just for practice for factoring by grouping. What are the factors of -18 that make +7? +9 and -2 do the job. And when you're factoring the bottom one, factors of +2 that make -3 are -2 and -1. So the top ends up factoring like y +9, y -2, and the denominator factors y -2, y -1. Okay, so we're going to have to exclude +2 and +1. We don't care about the top. The top doesn't cause any exclusion issues, just the bottom. So you may even want to make a note to yourself right here that says, okay, y cannot be equal to 1 or 2. But then notice that this factor appears twice, so we can cancel it out. So down here we just end up with y +9 over y -1. But we still have to keep those excluded factors. Y can't be equal to 1 or 2. Okay, let's move on. Bottom one. So it says to multiply. When you multiply fractions, this is just the basic fraction multiplication from arithmetic. A over B times just the basic fraction multiplication we used in arithmetic. So if you have A over C, A over B times C over D, we just multiply straight across. So this is AC over BD. We don't have to worry about getting a common denominator till we start talking about addition. Anyway, first step here, let's multiply everything. Let's factor everything. So the top factor is going to be x -6, x +1. Bottom factor is going to be x -3, x +1. And then we have two sets of differences of squares on the second one. X -1, x +1, and then we have x -2, x +2. And then we just want to first write down all the things we're going to exclude. So we don't want what numbers? Well, x can't be equal to 3, can't be equal to -1, can't be equal to 2, and can't be equal to -2. I'll reorder those in increasing order next step. But basically, those are the ones we have to exclude, and then we can start canceling. So, and x +1 can go out here, and then I also have, is there anything else? I thought there'd be more. Nope, but just this. So then when I'm done, that's all I'm going to do is write down all the factors right next to each other. So top we end up with x -6, x -1, x +1. You just write them as one big fraction. That's all multiplication does. And then I don't even multiply them out. I just leave them like this. X -2, x +2, and we got four numbers we're excluding. X not equal to -2 is the smallest, -1, 2, and 3. You don't have to write them in increasing order, but I find it's easier for someone that's either grading them or trying to follow your work. Okay. Alright, so when we're dividing fractions, remember how this works. So if you have A over B divided by C over D, the way we do this is we turn it into a multiplication problem. So I was always taught copy, flip, multiply. So what does that mean? It means that you go ahead and you take the first fraction, you just copy it down again. You flip the second fraction, D over C, and then it turns into multiplication. So copy, flip, multiply. And then you write them as one big fraction, AD over BC. So let's first go ahead and work through this one by dividing. So first I'm going to factor, then I'm going to copy, flip, multiply. So we can turn the top, x squared minus 25, x minus 5, x plus 5. What can we do with the bottom of the fraction? Well, we can take out a GCF, 2, and it becomes x minus 1. And then I'm still going to keep the division symbol for now. I'll change it next step. We have x plus 5, x plus 5 when you factor the top. And then the next step, x plus 5, x minus 1. Okay, so let's figure out all the numbers that we have to exclude. So right now, x cannot be equal to 1 or negative 5. Those are the two numbers that are causing problems. And then we copy the first one, x minus 5, x plus 5, 2 times x minus 1, and then flip the second one, x plus 5, x minus 1, over x plus 5, x plus 5. And again, still we have x not equal. I'm going to write negative 5 first just because it's smaller now, increasing order. Okay, so I kind of ran out of space, but we just need to cancel terms at this point. So one copy of x plus 5 goes out. This one, still have one left over, I can go out with that one, and then x minus 1 can drop out with x minus 1. So we just end up with x minus 5 over 2, where x cannot be negative 5 or 1. And that's it. So division is really the same thing as multiplication. Okay, let's move on to adding. So when we add fractions, we have to have a common denominator. So if we do have a common denominator, what we do is we just put the numerators together. So in this expression, notice 6x plus 5 appears in the denominator of both, so we can just really add the tops and put it over the same denominator. 4x plus 1 plus 8x plus 9, and that just goes over 6x plus 5. Right? It's like if you would have 7 over 3 plus 8 over 3. This equals 7 plus 8 over 3. So the thing to keep in mind, which would be 15 over 3, which is 5. The thing to keep in mind when you are doing any operations with rational functions is you want to use fractions as your basis. So just anything you would do with a fraction, do with a rational function. So put our common terms together. 4x and 8x make 12x. 1 and 9 make 10. And then we also have 6x plus 5. This one's a little bit harder to figure out what value to exclude. Okay, let me do that just on a separate page. It's probably a good idea. So if you have 6x plus 5 on the bottom, we don't want that equal to 0, so just solve for x. So start by subtracting 5. So 6x shouldn't be equal to negative 5, and then divide by 6. So the value we want to exclude is x not equal to 5 over 6. So let's go back to this problem and remember that we don't want x to be equal to negative 5 over 6. Don't want x to be equal to negative 5 over 6. And then you could stop here, but you'd be a little early because on the top we still have a GCF, so things might simplify. So if we take out a 2, we see 6x plus 5 appear, and then we actually can cancel. So we end up with just the expression 2, where we need to avoid x being negative 5 over 6. And that's it when they have the same denominator. Pretty easy. We start to things get a little tricky when they have different denominators, as we'll see in this next expression. So the thing we want to do is we want to get the same denominator on both. Right now we have a factor of x plus 4 in the first expression and a factor of x plus 5 in the second. So what you have to do is you have to add that factor to each expression, and the only way you can do it is by multiplying by something equal to 1. So let's go back to where we were over here and let's review what it looks like when we had to add two numbers that, say, didn't have the same denominator. Say we wanted to add let's say 3 over 7 plus 2 over 5. Well, how did we add these fractions? Well, the first one we need to get a 5 in the bottom. So we're going to take 3 over 7 and we're going to multiply it by 5 over 5. And the second one, we're going to take 2 over 5 and multiply it by 7 over 7. And then both denominators will end up being 35. So multiplying across, we get 15 over 35 plus 14 over 35. And you can add them together and you end up with 15 plus 14 over 35, or 29 over 35. And that's your answer. So notice we took the factor we didn't have on the right expression, multiply the first one by 5 over 5, and we took the second fraction, didn't have a 7 in the bottom, so we multiplied by 7 over 7. We're going to do the same trick here with rational functions. So the first factor is missing x plus 5. So basically we're going to take this first expression and multiply by x plus 5 over x plus 5. And then we're going to take the second expression and we're going to multiply it by, you guessed it, x plus 4 over x plus 4. So then we can go ahead and write everything. I just like to put them next to each other, not really multiply anything out at first, just so I don't lose track of things. And so I can see my actual common denominator. So then I have 6x plus 4, and the denominators on both are exactly the same, x plus 4 and x plus 5. So then I can add these together, so I get 3 times x plus 5 plus 6 times x plus 4. And then the bottom just combines nicely into a single x plus 4 times x plus 5. Okay, one last thing. Normally you can multiply these out and combine them just to see if there's any further factorization. So if you do that, distribute, you'll get 3x plus 15 plus 6x plus 24 over x plus 4, x plus 5. I just want to see if there's any further we can go. So we end up with 9x plus 39 over x plus 4, x plus 5. And I can tell just from looking at it that there's no factors, no GCF. 39's, no, that's not true. We can actually take out a 3 on top, but the factor that'll be left over will not be either x plus 4 or x plus 5. Basically, if something were to cancel, we'd have to be able to take a 9 out of the top, so we're good stopping there. Okay, this next expression, let's start just by factoring the bottoms and seeing what factors are missing from each one. So the first one is going to be x plus 5, x minus 2. And the second expression is going to be x plus 3, x minus 2. So again, that's all I'm doing is factoring this and factoring that. If you have to do that on some scratch paper and take a little extra time, that's perfectly fine. So now that's all we have to do is kind of catalog our factors, and we want to make sure we have a copy of each one in the denominator. So the first expression, we have an x plus 5 and an x minus 2, and the second expression, we have an x plus 3 and an x minus 2. So what we're going to need to do is get an x plus 3 in the first fraction and an x plus 5 in the second fraction. So the first one we do 3x, x plus 5, x minus 2, and then we multiply by x plus 3 over x plus 3. The next one we have, sorry, I went a little too far. We have minus 2x over x plus 3 x minus 2, and we multiply by x plus 5 over x plus 5. So we end up with 3x, again just write them next to each other, and we'll combine later. And then the bottom is going to have an x plus 5, an x plus 3, and an x minus 2 in each one of them. So on the bottom, what do we have? X plus 5, x plus 3, x minus 2. I know these get pretty tiring, and there's a lot of steps, but you just pace yourself and, you know, do one and then come back to one later, and it won't be that bad. So now we combine the tops. So 3x, x plus 3, minus 2x, x plus 5, and then on the bottom, x plus 5, x plus 3, and x minus 2. And then I'm going to go ahead and multiply and combine the top just to see if anything changes. So 3x squared plus 9x. The second one will be minus 2x squared minus 10x. Remember to keep the negative when you distribute. And then the bottom is those three numbers, x plus 5, x plus 3, and x minus 2. And then this is going to combine. 3x squared minus x squared is just x squared. And then on the bottom, I'm going to have, so on top, 9x minus 10x is minus x. And then we have x plus 5, x plus 3, x minus 2. And then you can factor the top if you want, x times x minus 1, but you really don't need to because nothing's going to cancel. And that's it for that one. A lot of steps, but basically what did we do? Let's just review. We started with each expression, factor the denominator. Top one, x plus 5, x minus 2. Second factor, x plus 3, x minus 2. So review and make sure you can do that. And then we just cataloged our denominators. So each one had two factors right now. The first fraction did not have an x plus 3, whereas the second fraction did not have an x plus 5. So we took the first fraction and we multiplied by x plus 3 over x plus 3. Second fraction we multiplied by x plus 5 over x plus 5. And then came all the work. So we have the same denominator, we combined on top, and then multiplied out the top expressions and added our like terms. Okay. Alright, here we go. Two more problems left and then we are done. So let's look at some complex rational expressions. These are not as hard as they look. You've got fractions inside fractions. I know that's a really scary looking thing, but that's all we're going to do is first combine the top and second combine the bottom. So let's look at 1 plus 1 over x. How do we make that? Well, first one we're going to multiply by x over x, and then we'll have a common denominator. So we get x over x plus 1 over x, which gives me x plus 1 over x. So that's the top. How about the bottom? So let's just a reminder, top, bottom. We have 3 minus 1 over x. So again, we just take the first one and multiply by x over x. And we end up with 3x over x minus 1 over x, which gives 3x minus 1 over x. Important little thing to remember. Remember, when we have the number 3 and we multiply it by x over x, what is 3 as a fraction? It's just the number 3 divided by 1. So it's 3x over 1 times x, which is how I got 3x over x. Okay, so now we just convert the fraction that we have to x plus 1 over x, and then since the other thing's on the bottom, that's the same as doing division. So we're just dividing by 3x minus 1 over x. Okay, and how do we do division? Well, we copy we flip, and then we multiply. So notice the two values that x can't be here are, if we just want to do that for extra practice, x cannot be equal to 0 because the first one. And then what number times 3 when you take away 1 makes it 0? Well, if you do x equals 1/3, that'll make the bottom of the second one 0. So x can't be 0 or 1/3. Then we can put them together and we'll actually get the x's to cancel. So we can write this simplified function as x plus 1 over 3x minus 1, where x cannot be equal to 0 or 1/3. So it's actually not too bad. We just have to put together the top and the bottom separately and then do the copy, flip, multiply trick. Okay, good work on that one. Last one, a little more complicated, but you know, it's not as bad as it looks at first. Just do the same thing. So we take the top, and that is what? It's 3 over x minus 2. What do we need to do to get the common denominator of these two guys? Well, it's going to be x minus 2, x plus 2, so we need to multiply this guy by x plus 2 over x plus 2. And then 4 over x plus 2, we need to multiply by x minus 2 over x minus 2. So we're going to end up with 3x plus 2, and then I'm just going to combine the denominators in one step here, so we're going to get minus 4x minus 2, and then on the bottom you're going to get x plus 2x minus 2. And if you're looking ahead, you might notice that the bottom fraction, x squared minus 4, is really a factored version of x plus 2x minus 2. So when you combine, let's see if we can get anything fancy to happen. 3x plus 6 is going on top, and then when you distribute, minus 4x plus 8, and then we're dividing by x plus 2x minus 2. So we end up with what? Minus x plus 14 on top. So nothing too fancy there. I don't think. Let me just double check my work because sometimes I make mistakes too. 3x plus 6, negative 4x plus 8. It looks good to me. Okay, so let's go down and combine the bottom. Sorry. The bottom. Oh wait, the bottom I think is already just a single expression. So we're already ready to copy, flip, and multiply because we don't have to put any fractions together on the bottom. Yeah, so let's do the copy, flip, multiply bit. Kind of lost track of myself. So the top we have negative x plus 14 over x plus 2, x minus 2. And then it's divided by 7 over x squared minus 4, so it's really multiplied by x squared minus 4 over 7 when we turn it into multiplication. And remember that x squared minus 4 is really x plus 2x minus 2, so this perfect square, difference of squares, will actually cancel with both of these factors, and we just end up with negative x plus 14 over 7. And what could x not be? It couldn't be plus 2 or minus 2 if we want to keep the exclusions in order. Okay, so that's it for this video. Hopefully the last two didn't demoralize you too much. They're just kind of a little bit fancy, but you know, you just take it step by step, combine on the innermost set where you thought. Remember, originally I said big fractions like this, you pretend like the top and the bottom each has an implicit set of parentheses, and then you just go to work. Combine fractions wherever you can, and then just follow the steps. Remember, division is really just copy, flip, multiply. When you are adding fractions or subtracting, that's when we need to go ahead and find that common denominator to put them together. But anyway, great job on Module 2, and we will see you next week in Module 3. All right, bye.